Now, finally, we're going to talk about small sample hypothesis testing, which is also called the t-test. Okay, so it is usually advised for sample sizes less than 30. Here we cannot use, maybe it's obvious, we cannot use S instead of our sigma directly here, because we cannot assume that it approaches to normal distribution directly. We cannot assume this. So for this sense, we have another method here. It's proposed by W.S. Gossett, a scientist, in 1908, which is also called student t-distribution. T-distribution for this purpose. It means that we're not going to use our Z or standard normal distribution table here. We will rely on students' t-distribution table. It's a bit wider than normal. Its mean is still 0, but with more variance. Okay, that's it. That's the difference. Okay, your Z-test is supposed as something like this, standard 1, around 0, and you had 1, I think, as standard deviation, right? But this one is a bit more wider. This is again has 0 as reference point here as the middle value, but it's a bit more wide. It's showing just more variance here. We're talking about a table like this, and here what you have here will be your Z will be x minus mu. Okay, this is pretty similar, but this one over square root of n, right? And this is for your Z, but for your t, what you have here will be x again minus mu over s over square root of n here. Now we can use s right here, and for this purpose we use for the rejection region, we rely on n minus 1 as degree of freedom here. So by definition, it's something like this: minimum number of independent coordinates which can specify the position of the system completely. Okay, this is just the definition. You don't need to memorize anything, but if you want to study further, that could be your starting point or something. But the idea is you will rely on here in our t-table anymore, and suppose that again you have a one-tailed, okay, let's say 0.5 distribution or 0.5 rejection region or something like this, and suppose that you have 10 samples or 20 samples here. You just calculate n minus 1 here. If you have, suppose that 20 samples, you will look for 19 here, and you will find your rejection threshold here as, where is it? I think this one. Yes, this is how we will use the t-table instead of the z-table. That's it. And let's try to solve some examples from our textbook to make things more clear together.